So yeah, hello everyone. A very good evening to one and all of you. So I hope I'm audible and visible. Any one of you can confirm it in the chat box.
Yes, ma'am.
Yeah, my slides are visible.
Yes.
Okay. So let's wait for 5 to 10 minutes so that everyone can able to join this session. Uh, Within
Okay.
5 or to 10 minutes, I will start the session. Okay, let's start the session. Hello everyone, my name is Pooja Verma. I am PMRF Research Scholar from IIT Kharagpur. And instructor for this course is Professor Syamal Kumar Das Mandal, Advanced Technology Development Center, IIT Kharagpur. This is a week 1 live and interactive session on signal processing techniques and its applications. You can use chat box for asking and interacting. Otherwise, you can unmute yourself and ask questions. And please, during the class, mute yourself. Okay, so this is the course content which have been covered for this course. So I hope all of you have gone through this course content and week 1 video lectures. So first I will go through some theoretical concepts, then we will solve some problems. Okay, so first one is introduction. So here we will learn about some basic concepts on signal and signal processing. Then we will solve some problems. Okay, so first one, what is a signal? Signal, that means flow of information. Okay, so the term signal generally applied to something that conveys information. A signal can be defined by any physical quantity that varies with time, space, or any other independent variable or variables. Okay, so signals can be depend on one or more than one independent variables. So these are the examples of a signal. These two examples are the from the one variable signal. Here the signal is dependent on one independent variable, that is t, and this one is a this signal depends on two independent variables x and y. Both are the examples of a signal. So the independent variable in the mathematical representation of a signal may be either continuous or a discrete. Okay, so what is a continuous time signal? The continuous time signal is defined along a continuous of a time, or it can be represented by a continuous independent variable. It can be a any value. Okay, for example 1.5, 0.7, 0.8, any value it can be. The continuous time signals are also referred as a analog signal. The another one is a discrete time signals. Discrete time signals are defined at a discrete instant. Example either 1, 2, 3 at any instant. So independent variable has a discrete values. Okay, so discrete time signals are represented as a sequence of numbers. Okay, so for example, this is a continuous time signal. It can be any signal like this. This is an example of a continuous time signal. And another one is a discrete time signal. So it defined as a discrete instant of time. For example, it is a 1, 2, 3, and it can be it is a this value can be a continuous. So we will I hope all of you have been to the video lecture. There are different types of representation of a signals have been told in the class. So from there you can see. Okay, the next one is different types of signal. So a signal can be a many types. So first one is a multi-channel signal or multi-dimensional signal. So multi-channel signals are which are generated by a multiple sources. That means multiple sensors are called a multi-channel signal. This is a multi-channel signal. Here are four channels, that is S1, S2, S3 and S4. Four different channels have been generated signal. This is called multi-channel signal. And multi-dimensional signal can be a more than one dimension. Okay, so here in the multi-dimension, we have taken the example of image. Image is a two-dimensional signal. Already, I hope all of you know that. It can be represented in X or Y. Image is represented by I, X and Y, and it is also represented by a matrix. Okay, two-dimensional matrix, and it has a three values R, G, P. Any image can be a black and white, or it is a basically it is a combination of three channels or three colors. Okay, color image, that is called a color image. Okay, so image is an example of a multi-dimensional signal, and multi-channel signals are those channels which can be generated by a multiple sources or multiple sensors. Now, next, the other types of signals are continuous time signals, discrete time signals, deterministic and random signals, periodic and aperiodic signal, analog and digital signals. There is a energy signal and power signals are also there. We will study about that in the later course. Okay, so first one is a continuous time signal. So continuous time signal already told defined at every instant of time. It can be defined every instant of time and represented mathematically by x t. Okay, sine wave, ECG signals, and speech signals are the example of a continuous time signals. Okay, next one is a discrete time signal. Discrete time signal defined at a specific time interval, and it is represented by x of n, where x is an integer number. That means 1, 2, 3, 4, 5, like this. Okay, so examples of the discrete time signals are digital audio signals or sampled data. Examples of a multi-channel signal. The example is given. Any signal that is generated by multiple sources or multiple sensors. Okay. For example, if you are seeing any sensors, for example, your laptop or phone, it also have a multiple sensors that it can be generated by a multiple channels. Okay, any signal. Okay, next one is a deterministic and random signals. So deterministic signals can be described by mathematically with certainty. That means the signals which have the certainty, that is a sinusoidal signal, and random signals that does not have any. The random signals are the signals which have uncertain situation, or that are unpredictable. For example, there is a noise, any kind of thermal noise or weather noise, you can say. Noise, it can be in any form. Okay, so thermal noise in electronic circuits, here it is. So random signal that has a uncertain situation or unpredictable, which we cannot predict. So these are the random signal, and deterministic signal that can be described with a certainty, or we can describe the deterministic signal with some mathematically, but random signal we cannot describe it by a mathematical equations. Now next one is a periodic and aperiodic signal. The periodic signal is repeat at every regular interval. Any signal which can repeat at every regular interval, that is a periodic signal, that is a sinusoidal signal. And aperiodic signal that does not repeat over a time. For example, this signal, it cannot complete the overall cycle, so it is a aperiodic signal. Any signal, any other kind of signals are speech signal. Whatever we are speaking, it is not repeating over a time. It is an uncertain situation. Now next one is analog and digital signal. Analog signal is a continuous in time, amplitude and time. That is a voltage variation over a time, and this Digital signals are discrete in amplitude and time, both in digital. That means this one and this one, both are in discrete. For example, binary signal 0 or 1. These are the digital signals. Now next one is the characteristics of signal. What are the different characteristics of the signals? So the three main fundamental characteristics of the signal is amplitude, frequency and phase. Amplitude is the magnitude of a signal at any given point of time. So here we have taken one equation, that is a cos omega t plus theta, where a is the amplitude, that means peak value of any signal. Example, this one, amplitude. Okay, peak value, peak to peak value. And next one is frequency, the number of cycles of a signal complete in a second. Already we know that this is called t. So in seconds, it is measured in a hertz. So frequency is omega. It is basically called angular frequency, and f is 2 pi omega by 2 pi. Basically omega is equal to 2 pi f, where omega is angular frequency and f is a frequency. It is represented in hertz, and angular frequency is represented as a radian per second. Okay, now next one is phase, that is theta. Shift the signal in time. Okay, for example, we want to shift that signal 90 degree or 80 degree, 0, 90, 80, 180, 270. Already we know that shift like in this theta. Okay, so these is the main three characteristic of any signal: amplitude, frequency, and phase. Okay, now next one is signal processing. So what is signal processing? How we can process? We already we know that the signal, and now next how we can process the signal. So already we know that in a real life everything is in analog. So in analog, whatever we are speaking, whatever we everything is going on, that is in real and in analog in nature. So we cannot process this directly on any. So we have to convert it into a digital, then so that we can process it. Okay, so here it is required the signal processing. So the process of operation in which the characteristic of the of a signal, that is amplitude, shape, phase or frequency, goes on a change known as a signal processing. So here first an analog to digital converter. First we are giving the analog input to a signal, then we convert it to analog to digital. Why analog to digital converter? Then we will find a digital input, and the digital signal processor will process that signal, and then again we will convert it digital to by digital to analog converter, then analog output. For example, whatever I am speaking, that is an analog in nature. It is going through my microphone, and microphone is connected to my system. So the system is digital signal processor which transfers via internet, and then in your side maybe a digital to analog converter is, then you can able to listen my voice. Okay, so basic steps, three basic steps are there to analog to digital conversion, that is sampling, quantization, then encoding. Sampling, convert the signal into a discrete time interval. There here some concepts are there, we will discuss it. And then quantization, assign discrete amplitude level to a sampled signal, then encode the quantized signal in a binary form. So these three is the basic steps to analog to digital convert. So for sampling we have to use the sampling theorem. Okay, so sampling of analog signal any signal that is x of at is obtained by taking samples at every t second, and for every t second, here it is a 1 2 3, every t seconds we are taking, t is 1 2 3, and t is 1 by fs, where fs is the sampling frequency, or you can say that sampling rate. Okay, so how we are converting to analog to digital? By taking samples at every t second. So this is a circuit, here we are giving, then we are sampling at every t seconds, fs is equal to 1 by 2, then we are getting x of n. Here the analog signal, here we are getting the output of in a discrete form. Okay, after that we will quantize the signal. Okay, so how we are sampling? By a Nyquist criteria. Okay, that is called a continuous time signal that is a band limited if its frequency content is confined to a maximum frequency, can be completely represented by its discrete sample if the sampling frequency is at least twice of the frequency component, that is f was is greater than equal to 2 f maximum. Okay, any signal that is containing the frequencies, we will see that is for example x at is equal to a cos omega t plus b cos omega 1, here omega 2 t. So these contain the frequencies, or we can write it omega 2 pi f1 t plus 2 pi f2 t, a cos 2 pi f1 t plus b cos 2 pi f2 t. Okay, so by taking the maximum frequency component, we will sample it. It is also called a Nyquist theorem, and fs is called sampling frequency. F maximum is the maximum frequency present in the signal, and 2fm it is a Nyquist rate, minimum sampling rate to avoiding aliasing. Okay, if the fs is less than 2fm, then there is a aliasing condition. We cannot recover signal at the output end. So fs must be greater than equal to 2fm. Okay. Now next one is a quantization. So quantization, what is mean by aliasing? Okay, when we are sampling the signal, okay, so when we are sampling, if fs is greater than equal to 2fm, then we will sample like this. But if the fs is less than 2fm, then the signal will coincide to each other like this. So this effect, here we will lost our signal sub information, like, so this is called aliasing effect. If signal is coincide to each other, so here we will lost some information here. If fs is less than 2fm, then this is called a aliasing. Okay, now next one is quantization. So quantization is the process of mapping a continuous range of values from analog signal to a finite set of discrete level. Okay, already told here we are getting when we are sampling. So these are the something we are getting. Here it is in discrete, but this value is in continuous in nature. So that we will quantize these values so that we can get the discrete in amplitude also. So that's why we are quantizing the signal. So what we are doing, whatever we are the signal here we are getting, we quantize this vertical into a 2 to the power n number of labels. Okay, quantization label. So the number of discrete levels is determined by the bit depth. L is equal to, here n can be a 2, 4, any value. Okay, where n is the number of bits, how many bits we want to quantize this. It depends on that. During quantization, there are some types of error also occurred, that is called quantization error or quantization noise. That means the difference between the actual sampled value and its quantized approximate. When we approximate the signal, there should be some miss actual value and the assumed value. Okay, and quantized approximation. So this is called a quantization error, and it is represented by Q or delta. This is called quantization label, where X, capital M, is the maximum value of Xn. This is the Xn signal. When we are converting Xa2 to Xn, that means sampling, and Xm is the minimum value of Xn divided by 2 to the power n. And the quantization error can be vary minus Q by 2 to plus Q by 2, where Q is the quantization label. Okay. Now, next one is the concept of frequency in continuous time and discrete time. So, continuous time signal, in a continuous time, the omega is represented by this omega, and in a discrete time, it is represented by this one, that is called, this is called also omega, you can say W. Here F is a maximum, F is capital in a continuous time, and discrete time F is a small letter. Omega, here it is a radian per second, and F is in hertz, and here omega is radian per sample, not a second, here radian in a discrete time, and F is in cycle per sample. In a continuous time, omega and F will be very minus infinite to infinite, and in a discrete time it will be very minus pi to pi, and it is minus 1 by 2 to 1 by 2. And already we know that here omega is a 2 pi f, right? And f is equal to 1 by t. Okay, 1 by t. So from here we can find out the relation between the continuous time and discrete time. Okay, so here omega can be at 2 pi by t also. This formula will, we need to find out some relation. Okay, and this is a relation between the analog frequency, continuous frequency to discrete frequency. This is a omega, omega by ts, or f is equal to f fs. Okay, already we know that sampling frequency, fs is the sampling frequency, and ts is the sampling rate, that is 1 by fs. Okay, so these are the some concepts which have been covered this week. So now we will move to the some questions, problems, which may be help you solve your assignment problem. Okay, so the first question is, suppose there is an analog signal, that is xa of t, that is equal to 9 sine 460 pi t plus 12 sine 340 pi t. The minimum sampling frequency to avoid aliasing is, option A is 340 Hz, option B is 170 Hz, option C is 460 Hz, and option D is 230 Hz. So any one of you want to answer this question? Please answer, then we will I will describe it in detail how we can solve this type of question. Yeah, try to answer this question. We need to find the minimum sampling frequency to avoid aliasing. That means we have to obey the Nyquist
criteria.
Yeah, Nyquist sampling frequency. That already we know that Fs must be greater than equal to 2Fm, or you can say F maximum. So yeah, anyone of you try to, yes, yeah, try to answer in the chat box. Yeah, correct, Aparna. Yeah, please, everyone, please answer in the chat box. So okay, this is a analog signal, already we know it, 9 sine 460 pi t plus 12 sine 345 t, and already we know that omega is equal to 2 pi f, right? So here it is in 2 pi f. We can here we can calculate the f. Yeah, correct one. Yeah, please, everyone, try to solve it. Okay, so here two frequency components are there. So I am taking as a omega 1 f1 and omega 2 f2. Okay, so here omega 1 is equal to 2 pi f1. Here already here it is there pi. That means it is in that form. So if we do that, so how much? If we just divide it, 2 into what is 235, right? So now it is in this form, 2 pi into 230. That means what is the f1? F1 is 230 hertz. Similarly, for omega 2, 2 pi f2, that means 2 into 170 pi. So f2 is equal to 170, right? So already we know that we need to find out f maximum, right? So f max is equal to maximum of f1 and f2. So maximum of 230 hertz and 170 hertz. So which is the maximum value? 230 hertz, right? So f max is equal to 230 hertz. Now already we know that the Nyquist sampling rate, that is Fs must be greater than equal to 2f maximum. So what will be the Fs to avoid the aliasing? Sampling frequency, that is 2 into 230 hertz. So we will get here 460 hertz. So Fs is equal to 460 hertz. Now let's check on the options. So option C is the correct answer for this question. Means Fs is equal to 460 hertz. Here I am writing 460 hertz. This is the answer. Okay. So I hope all of you have solved this question. Have you understand this question? Yeah. Okay. So now moving to the next question. Okay. So next question is y a of t is equal to 3 cos 400 pi t plus 6 cos 380 pi t minus 12 cos 240 pi t. Be an analog signal. Determine the discrete time signal after sampling if sampled at a fs is equal to 840 hertz. What will be the corresponding discrete time signal? The analog signal is given. We need to find out the discrete time signal. How we can convert it? Anyone? You guys want to try? Please try this question. I will describe it. Okay, try to answer in the chat box. Okay, so let's solve this question. Yes, yes, right, right. Yeah, everywhere at a place of t. So the analog signal is y a of t. This is the y equal to 3 cos 400 pi t plus 6 cos 380 pi t minus 12 cos 240 pi t. Okay, and here sampling frequency is given also 840 hertz. So to convert analog signal to a digital, what we need to do, we have to put at a place of t and t, yes, or ts. Already we know that ts is equal to 1 by fs, that is fs is a sampling frequency, so n by fs, okay, in place of t. So ya, you can write it nt or nts, 3 cos, we can also in terms of 2 pi n, or we can write it like this, only 400 pi in a place of n by fs, right? N by fs plus 6 cos 380 pi n divided by fs minus 12 cos 240 pi n divided by fs. Okay, now put the value of fs, that is 840 hertz. So 3 cos 400 pi n divided by 840 plus 6 cos 380 pi n divided by 840 hertz minus 12 cos 240 pi n divided by 840 hertz. Now what if we cancel out the 3 cos, what will be the 0 and 0? what will be the after just cancelling out 10 pi n divided by 21, right? Plus 6 cos. Here also, if you cancel out these things, what will left? 19 pi n divided by 42. Now next one is minus 12 cos. Here also 12 2 ja and 12 7 ja, right? So 2 pi n divided by 7. Okay. So by putting the at a place of t is equal to nts or n by fs, you will get, and then divide by sampling frequency. Sampling frequency fs is given 840 hertz. Put it and see if there is a cancel out these things, then calculate, then you will get this answer: 3 cos 10 pi n divided by 21 plus 6 cos 19 pi n divided by 42 minus 12 cos 2 pi n 2 pi by 7 n. You can say like this. Okay, now check in the answers which option is a correct. Which one is 3 cos 10 pi divided by 21 n plus 6 cos 19 pi n 42 minus 12 cos 2 pi n by 7. So option A is the correct answer for this question. Okay. Uh, Kavita, what you want to say? Don't. Yeah, answer A is the correct answer. Okay. So I hope all of you have understand this question. If you have any doubt, you can ask. Otherwise, we can move to the next question. Okay. So can we move to the next question? Okay. So moving to the next question. Okay. So next question is XA of t be an analog signal expressed as XA of t is written as 6 sin 300 pi t plus 20 sin 500 pi t plus 15 sin 1000 pi t, and it is marked as a first, second and third. That means three signal frequency or three components are there. Okay, if we sampled it, fs is equal to 820 hertz, that means sampling frequency of 820 hertz, and converted it into a discrete signal, which frequency components will get distorted after recovering analog signal with the same sampling frequency. So which signal, they are asking which signal will get distorted after converting the discrete signal, then after that again when we are recovering our analog signal, which signal will get distorted. Options are A first and 1 and 2, option B is second and third, option C is first and third frequency component, or option D third only. Which signal will get distorted? Okay, let's check. We will see it. First, read the question carefully. Okay. So if we sampled it at 820 hertz, and converted it into a discrete signal, which frequency component will get distorted after recovering again to an analog signal with the same sampling frequency will be there. Okay, first and third, someone is saying, and some people are saying B, second and third. Okay, so let's see. Yeah, someone is saying third, D only. Okay, so let's see. So here x a of t is given. So first, you can check, you can solve this question in many ways. Okay, so first one is first convert it into a digital, then check, then again convert it into analog. If the same frequency, same signal we will get, then that means everything is correct. No frequency component will be distorted. If the value will not be same, that means any one of them are distorted. So first way, this is the first way. The another way, already we know that sampling theorem. Okay, Nyquist sampling rate. That is, Fs must be greater than equal to 2 Fm, right? That means if sampling frequency is greater than equal to 2 Fm, then signal will not distorted. That means we will get the correct. If Fs is less than 2 Fm, then the signal will get distorted. So first we need to find out the three frequency component. That means F1, F1, F2 and F3. So what will be the F1, the first frequency component? I am writing. So here it is a, this is the F1. So here it is a 300 pi t. So if we, here it is a omega 1. Okay, so 150, right? So F1 will be 150 hertz here. Similarly, omega 2 is 500 pi t, or you can say 500 pi. So if we again 2 pi into 250, so F2 is 250. Similarly, omega 3 is 1000 pi, 2 pi into 500. So F3 is 500, right? Now, actually here three components are there. So we need to find out the three different sampling frequencies so that we can analyze, because they are asking first, second or third, which frequency component will get distorted. Okay. So first one, Fs1 is equal to 2F1, right? Fm, here I am taking this one. So we will get 300 hertz, and Fs, here it is a 820 hertz. Okay, so that means 820 hertz is greater than 300 hertz. That means this frequency component will remain, that will not get distorted because its sampling frequency is greater here. So we are asking for, if sampling frequency is greater than this one, then the signal will not get distorted. Okay, so now second one, for this one, 2F2, what will be the value? 500, right? So here again 820 hertz is greater than 500 hertz. That means the second frequency component also will not get distorted, right? So that means first and second, after recovering, that will not get distorted. It will be the same. Okay. Now check for the third one, Fs3. That means 2f, here f2. Okay, f3. So f3 is 500 hertz, 2, so it will be 1000 hertz. And here, if you check, 820 is less than 1000 hertz. Here, the 2 FM, this is greater than, that means that signal, the third frequency component will get distorted. Okay, so that means option D, only third component, frequency component, will not get recovered after analog recovery when we convert the analog signal. So only third component, not a second and third. These are the correct one. No, this one is only third frequency component will not recover the analog signal. It will get distorted. Okay. So now you understand this question. Okay. Now you all of understand this question. Why the third frequency component will get distorted? Okay. So I hope all of you have understand this question. So moving to the next question. Now, next question is a full scale voltage of 0 to 10 volt. Okay, full scale voltage is given. Determine the resolution of 7-bit analog to digital converter. Okay, that means n is given here. That is 7 bit. And full scale voltage, we can represent the full scale voltage VFS is 10 volt, 0 to 10 volt. The maximum is 10 volt. Okay, so we need to find out the resolution of this. Determine the resolution of a 7-bit ADC. How we can find it? Anyone of you have any idea? Try to solve it or answer in the chat box. Okay, let's solve it. So the full scale output voltage of a given resolution is, the formula is full scale voltage of a given resolution is Fs is equal to, yeah, 2 to the power n minus 1, this is n minus 1 into resolution. We are representing resolution by a delta. Okay, resolution. We are representing resolution by a delta. Okay. So here we need to find out the resolution, right? Full scale voltage is given. So from here we can find out. So VFS is 2 to the power n minus 1. So full scale voltage is given, that is 10 volt. VFS is given, that is 10 volt. N is also given, that is 7 volt. Already I have written. So 10 divided by 2 to the power 7 minus 1. So now you can calculate it. So try to answer. So 10 divided by 127. What you will get? 0.0787. If you convert it, you will get 78.7 millivolt, or approximately 78 here, because 79 is not an option, so we can take 78 millivolt. So option C is the correct answer for this question. Okay, not A, it's C. Okay, so correct answer is option C. So I hope you have understand this question. So we can move to the next question. So all of you please solve this solve with me or solve it parallelly so that you can able to solve the assignment problems. Okay, so I hope all of you have understand this question. So moving to the next question. Okay, so next question is a signal with a maximum frequency of 40 kilohertz is sampled at a Nyquist rate. The, the time interval between two successive samples is. Options are given. So any one of you try to answer this question. The maximum frequency is given, which is sampled at a Nyquist rate. What will be the time interval between the two successive samples? This is a very easy question, just based on a Nyquist rate. So try to solve it or answer in the chat box. Here I am trying to introduce Fm is given. Okay, F maximum you can say that is 40 kilo or hertz. Already we know that Nyquist rate Fs must be greater than to F maximum, right? So what can be answer? Okay, convincing B or C. Okay, so F maximum is given. So first we will find out the Nyquist rate. So 2 into 40 kilohertz, right? It is a 80 kilohertz, right? So time interval between the two successive samples. What is this? Time interval between two successive samples can be find out by a TS. It is represented by TS, right? What is this? Time interval between two. That means this, and what will be the time interval between these two? So it can be find out by a sampling frequency 1 by Fs, right? So Fs we get from the Nyquist rate 1 by 80 kilohertz. That means 80. So if you divide it, so you will get 10 to the power minus 4 divided by 8. Further, you will get it 0.125 into 10 to the power minus 4. Again, if you just rearrange it, you will get 10 to the power minus 6. That means 12.5 microsecond, right? So option C is the correct one. Option C is the correct answer. So this is the 12.5 microseconds. Okay. Yeah, option C is the correct answer. Okay. So I hope all of you have understood this question. Moving to the next question. So now, next question is a speech signal is recorded using CPM WAV format. How much memory is required to store 30 millisecond signal if Fs is equal to 16 kilohertz encoded with 16 bits and recorded in mono? Okay, so Fs is given and how many bits it is encoded. Now for it is also given for memory to require how much memory we need to require store 30 milliseconds. And how many questions we are going to solve in this session? I have taken 18 questions right now. Okay. Hello. Oh, hello everyone. Yeah, now my slides are visible.
Yes, ma'am.
Okay. So 18 question we are going to solve in this session. We will try from the next onwards 20 questions. So yeah, try to solve this question and answer in the chat box, then I will describe it. So here it is given a speech signal is recorded in WAV format. How much they are asking how much memory required to store a 30 millisecond signal. Okay. fs is given, that is 16 kilohertz, and encoded with 16 bit. We have encoded it with a 16 bit and recorded in mono. Okay. So total number of samples, how many total number of samples will be there for this time, for this mixed time? So total number of first we need to find out total number of how many samples we required for to store a 30 millisecond signal. So for this, the formula is F was, that means sampling frequency, multiplied by total time of recording. Total time of recording. Okay, so fs is 16 kilohertz, that means 16 into 10 to the power 3. And the total time, how much time they have given to store 30 millisecond, that means 30 into 10 to the power minus 3. Right? Here, if you calculate it, then you will get 480 samples. That means we need to store 480 samples. So to store a 480 samples, how much memory we require? Now we are going to calculate it. So here it is given the encoded with 16 bit. Okay, but we can calculate in this format also 16 bits, but they are asking in the options in terms of bytes. So in the 16 bit, how many bytes will be there? One byte contain how many bits? Any one of you know that? In one byte, how many bits are there? Please answer at least this question. One byte is equal to how many bits? Yeah, in one byte there are 8 bits. Okay, so for 16 bits, how many bytes will be there? That means 2 bytes. Okay, so they are telling that encoded with 16 bits or 2 bytes. Okay, so for storing, that means for storing one sample, 2 bytes are required. Okay, because they are encoded with 16 bits. We can also say for storing one sample 16 bits are required, but they are asking in bytes. So we have to convert it into byte in terms of byte. So total. So now how many samples are there? So to store 480 samples, total memory required required. That means for one sample 2 bytes are required. So to store 480 samples, so 480 into 2, right? 2 bytes. So what we will get if you multiply 960 bytes. So total memory required to store 2 bytes of 480 samples, that is 960 bytes. Okay, so option D is the correct answer for this question. So yeah, all of you getting these questions? Are you solving with me? Please answer in the chat box. Okay. Yeah, someone is asking mono means. Mono means uh, the sound that is coming from one. That means in one direction. Okay. Yeah. Okay. Can we move to the next question? Okay. So moving to the next question. Okay. Now next question is the period of a signal xt is equal to 10 sine 12 pi t plus 14 cos 18 pi t. What is the period of this signal? So how we can find it out? Can we get this session PDF after completion? Yeah. I will upload it. You can access it from the Swayam portal, NPTEL. I will upload this PDF there. But questions are there. For the solution, the YouTube videos are there. Okay. So how we can find out the period of the signal? Okay. So the signal is given as 10 sine 12 pi t plus 14 cos 18 pi t. Okay, D option. Yeah. Let's see that. The period of a signal is described by basically that is represented by t. It is 2 pi by omega. Okay, in a analog or in a continuous. Okay. So what are the values of omega? Omega 1 is 12 pi, omega 2 is 18 pi, right? So we can solve it by a two ways. Whatever you feel comfortable, you can solve it. So from here we can also what will be the common factor, how we can represent it? This one. Okay, so from here you can find out t is equal to 2 pi by t1. We can say that t omega 1. So 2 pi by 12 pi, we will get 1 by 6 here. T2 will be 2 pi by omega 2. So that means 2 pi by 18 pi. You will get 1 by 9. Okay. So what will be the fundamental time period or t? So you can find out HCF of t1 or t2. So what will be the common factor? 1 by 2 into 3. Here 1 by 3 into 3. Right? So what will be the common? 1 by 3. Right? So the period of the signal is 1 by 3. That means the other way to solve HCF, you can directly here from here HCF of omega 1 comma omega 2. So what will be the common factor? 12 pi into 16 pi. Sorry, it is 18. Right? So what will be the common factor? 3. Right? 3 pi. No, here it is a 6 pi. 6 pi is the common. So from here you can say that it is a omega naught. So omega naught is equal to also 2 pi by t naught. So we need to find out t naught. So 2 pi by omega naught, that is 6 pi. So here from here you can also find out 1 by 3. Whatever way you find easy, you can solve it to find out the period of a signal. Okay. So option B is the correct answer for this question. Okay. So I hope all of you have understand this question. It's not 1 by 9. Option B is the correct answer, not a D. We have to take a common factor to find out the period of a signal. Okay. Okay, so moving to the next question. So yeah, next question is figure 1. That means this figure shows a ideal C2D converter that samples xt with a sampling period ts to produce a discrete time signal x of n. That means xt is given to the input of ideal C2D converter with the sampling rate ts, and ts is equal to 1 by fs that produce the output x of n. That means in digital form. Now again this digital signal is given to D to C converter. Okay, the sampling rate is same, that is ts is equal to 1 by fs. Signal from a samples x of n. Suppose x of t is given here. That means this signal is given. Xt is equal to 4 sine 300 pi t minus 12 cos 600 pi t. What is the minimum sampling frequency fs that can be used in the above system so that yt is equal to xt? That means input and output will be same. What will be the minimum sampling frequency? Okay, so they are asking also fs. Already we know that from the Nyquist criteria fs should be greater than 2f maximum, right? So now we have to find out the f maximum value, then we will get fs. Okay, because fs is depend on the f to f maximum value. So from here we can get xt is given, that is 4 sine 300 pi t minus 12 cos 600 pi t. So here f1 first, the first frequency component. So omega 1 is 300 pi. F1 will be, what will be the F1? 2 into 150 pi, right? So F1 will be 150. Now similarly omega 2 is 600 pi. If we convert it 2 into 300 pi. So F2 will be 300. So how we can get the F maximum value? Maximum of f1 comma f2. So what will be the maximum? f1 is 150 and f2 is 300. So what is the maximum value? I am writing here, right? F maximum will be the 300 hertz, right? Okay, now F maximum we got. So from here we can find out the Fs. Fs is equal to 2 into 300. So 600 hertz. Okay, so now which option is correct for this question? Yeah, option D is the correct answer. Yeah, option D is the correct answer. Fs is equal to 600 hertz. Here, final solution is here. Okay, so option D is the correct answer. Okay, okay. So I hope all of you have understand answer as well as answer in the chat box. So moving to the next question. Yeah. So next question is, which of the following is our multi-channel signal? Okay. So option A is Dolby audio, option B is stereo audio, option C is ECD, or option D is all of these. So which one is a multi-channel signal? So already explanation in detail is given in this for this question. So yeah, first we see options by option. So Dolby, what is a Dolby audio? Dolby audio is a multi-channel audio format when often used in home theater system. Okay, so it involves multiple audio channels. For example, 5.1, 7.1 surround audio for immersive sound. Okay, so or Dolby audio is a multi-channel audio. That means, and next one is a stereo audio. So stereo audio consists of two channels, left and right. So it is also coming from the multiple more than one channel. So it is a basic form of multi-channel audio. Okay. So audio using music playback systems and headphones, that is a stereo audio. The stereo audio is also a multi-channel signal. Okay, now next one is ECG, electrocardiogram. So ECG records electricity activity of the heart using multiple leads, multiple channels. If you have seen the ECG machine, so you can find it multiple channels they are using to record the heart activity. Okay, so it is also form of a multi-channel signal. So that means all of these are the example of a multi-channel signal: Dolby audio, studio or stereo audio, and ECG. So option D is the correct answer for this question. Okay. Okay, so someone is asking also what are the examples of a multi-channel. So these are the example. These are also example of multi-channel audio, multi-channel signal. Okay, so I hope all of you have understand. So moving to the next question. Okay, so next question is a speech signal is shown in figure 2. Is this figure a speech signal is represented? Determine the fundamental period. That is, here the fundamental period is represented by a f naught. How we can find it out? Here the one period is given here to here, that is L is equal to 11.6 millisecond. Okay, so from here to here it is given. L represents the period of a waveform, and fundamental period f is a 1 by L, or you can say the Fs is equal to 1 by Ts because it is represented in time. So to find out the frequency, we have to 1 by T, but here it is given in form of L and F naught. Okay, so just 1 by 11.6 millisecond. If you divide it and then multiply it, you will get the answer. What will be the answer? Please answer in the chat box at least now. Calculate it. Here it is given in form of L. L is the one period of a waveform. Okay, here it is given. Normally we are saying it as a form of T, but here in the question it is written the one period is represented by a L. Okay, L and T are same. So here it is a 1 by 11.6 milliseconds. So 10 to the power minus 6, 3, 10 to the power 3 divided by 11.6. If you multiply, divide it, you will get it 86.2 hertz. Just calculate it. Okay. So option B is the correct answer for this question. Yeah, option B is the correct answer. Okay. So all of you have understand this question. So moving to the next question. So now next question is, consider an analog signal xa of t 5 sine 420 pi t plus 8 cos 840 pi t. Determine the discrete time signal after sampling the signal with sampling frequency fs. Fs given as a 1260 hertz. So just we have to convert this analog signal into a digital signal or discrete time signal. So try to answer this question or solve this question. I am waiting. Try to answer this question. Any one of you? Okay, solve it. Okay, great. So here analog signal is given as xa of t is equal to 5 sine 420 pi t plus 8 cos 840 pi t. As already told that t is equal to nts and ts is equal to 1 by fs. So if you do that, n by fs, because ts is equal to 1 by fs. Okay, just put in the place of t is equal to nts, we will get a digital signal nt, that means 5 sine 420 pi n divided by fs plus 8 cos 840 pi n divided by fs. Fs is already given 1260 hertz. So 5 sine 420 pi divided by 1260 n plus 8 cos 840 pi divided by 1260 n. Right? Now multiply it. Divide it. You will get, what will we get? If you just divide it, you will get pi by 3 n. That will 3. Now similarly here also you will get I think 24, yeah, plus 8 cos 2 pi by 3 n. Okay, if you divide it, you will get 5 sin pi by 3 n plus 8 cos 2 pi by 3 n. So which option is correct? 5 sine pi by 3n plus 8 cos 2 pi by 3n. Okay, so option B is the correct answer for this question. Yeah, option B is the correct answer. Okay, so already you have solved this question. So moving to the next question now. Next question. So next question is figure 2. This figure shows the ideal A to D converter that samples XT with a sampling period Ts to produce a discrete time signal. That means first analog signal is given, analog to digital with sampling rate is given 5 milliseconds for this. Now that will generate a discrete signal. Please repeat question number 9. Okay, I will repeat it in later. Just first we will solve it. Okay, just check it. Okay, question number 9 is a theoretical question. Which of the following is our multi-channel signal? So three options are given: audio, sorry, Dolby audio, stereo audio, and ECG. So what if these are the multi-channel signal? Okay, so what is Dolby audio? So Dolby audio basically used in home theater and it is coming from multiple channels. So multiple channels are also the example 5.1 or 7.1 sound. So that is coming from the multiple channels. That means Dolby audio is a multi-channel signal and same as a stereo audio. Stereo audio has two channels, left and right. For example, in your headphones also have left and right channels. So it is coming also more than one channel. So we can take it as a multi-channel. And the next is ECG. That means electrocardiogram, right? So what ECG do? ECG monitor the heart activity of a heart. So when we are monitoring the heart activity, we are just connecting multiple wires. If you have seen ECG, so that is also coming from we are recording from multiple channels. So it is also a multi-channel signal. So these three are the multi-channel signals. That means all of these three are the multi-channel signals. So that's why all of these options are correct. Okay. Okay. So I hope you have got this question. So now moving to our next question. Okay, so next question here, analog to digital, it is converted into a digital signal. Then again, we have to convert digital to analog signal. The sampling frequency in both the cases are different. Here the sampling rate is t is equal to 5 milliseconds. Here the sampling rate is 2 milliseconds. After that, we are applying the filter, and after filtering, the final output signal is y of at. So from here we have to calculate the y of t from the sample x of n. So here already xa of t is given. If the signal is xa of t applied at the input here, determine the expression for the output. That means ya of t. So xa of t is given. So just try to convert it analog into a digital. Can you convert it? Xa of t is given. Just put here n into ts in place of t. Okay. From here, for analog to digital converter, t is given. That is 5 millisecond. From here, you can calculate f also 1 by 5 millisecond, right? So 10 to the power 3 divided by 5. What you will get? 200 hertz. For this sampling frequency is 200 hertz for this analog to digital converter. Similarly, here the second fs is 1 by ts. So 1 by 2 millisecond, you will get 500 hertz, right? For this sampling frequency. So that means n by fs. So just put in this equation x of nt is equal to 10 cos 50 pi t. In place of t, we have to put n by fs plus 3 cos 450 pi divided by fs. So first analog to digital converter fs is 200 hertz, right? So 10 cos 50 pi n divided by 200 plus 3 cos 450 pi divided by 200. Its n is there. So just we have to do calculations. Okay. So if you divide it pi by how much we will get? 4n, right here, plus 3 cos. Again, if you divide it, 9 pi by 4n. So we can write it in form of 2 pi plus theta here. Can you write it? 9 pi, we can convert this 9 cos 9 pi by 4 and we can write it like this 2 pi plus pi, sorry, here it is not here, minus 2 pi by 4 and we can write it here 2 pi plus pi by 4, so 8 plus 9. If you convert it, so what we will get? Pi by 4 and 2 pi plus theta. Cos 2 pi plus theta is equal to cos theta, right? So from here we can write it also 10 cos pi by 4 n plus 3 cos pi by 4n. We can write it like this, right? Now 10 cos pi by 4n plus 3 cos pi by 4n, we can directly add it here. That means 13, 10 plus 13. The amplitudes will be added because the frequency and phase are same. Then we can add these signals. So 13 cos pi by 4n. Okay. So now we have got x of n. That means 13 cos pi by n. Okay. So actually I have to remove it from here because I don't have space. So can I remove it? Okay, I can take the other slide also. Just a minute. Okay, so what we have got? We have got xn is equal to 13 cos pi by 4 n, right? Now again, what is in answer in this question? Again, x of n we have got. Again, we have to convert it into analog. When sampling frequency is sampling period is 2 milliseconds. If you calculate it, you will get the sampling frequency 500 hertz. Okay. Okay. So t is given as a 2 millisecond. F is equal to 1 by t. Then you will get 1 by 2 into 10 to the power minus 3. If you calculate it by 2, you will get 500 hertz. Okay. Again, now we have converted it into a analog form, right? So already we know that when we are converting to digital to analog, t is equal to nt we are putting. Now it is in the form of n, so T by T. In place of n, we have to put it here, or you can say T into Fs. Okay, so that means here T into Fs. Okay, so 13 cos pi by 4. In place of n, we have to put T into Fs, right? So 13 cos pi by 4 T into Fs. Fs means 500 hertz. So 13, again we need to rearrange this, 500 pi T divided by 4. Now just divide it. You will get how much? 1, 2 and 5. Yes. 13 cos 125 pi T. So what we have got? Again we have got this analog output here, y t. Again we have to apply a filter, but there is a no frequency, no cutoff is given. So y, this signal is equal to this signal. That means ya of t is equal to 13 cos 125 is the final output. Okay, so let's check by the options which option is correct. So option C is matching with the answer 13 cos 125 pi t. So option C is the correct answer for this question. Okay, so just remember this trick, cos 2 pi plus 2 pi plus theta concept. Otherwise, you correct answer you will not get. Okay, so have you understand this question? Have you got it? Please answer in the chat box. Have you got this question?
Yes, ma'am.
Okay, so can we move to the next question? Okay, so moving to the next question. Okay, so yeah, next question. So next question is a discrete signal x of n is equal to 7 cos 3 pi n divided by 8 is converted into analog signal with sampling frequency fs is equal to 10 kilohertz. Determine the analog frequency of the signal. Okay, so already it is given in a digital discrete signal. We have to convert it into analog. Please convert it and answer in the chat box. Please try to solve this question. I will solve it. Okay, so x of n is given as a 7 cos 3 pi n divided by 8. Sampling frequency fs is given as a 10 kilohertz. Right? Now we have to convert it into a analog. So already we know that when we are converting to analog to digital, at the place of t we are putting n t, right? Now in place of n, what we can put? T by t. From here we can get. Okay, already we know that t is equal to 1 by f or fs, you can say. So if we put here 1 by fs, so we will get t into fs, right? So now put in place of n here t into fs. So x of t into fs is equal to 7 cos 3 pi by 8 t into fs. Fs is given 10 kilohertz. So 7 cos 3 pi by 8 into 10 into 10 to the power 3 t, right? Now again just try to solve it and also they are asking only for analog frequency. Okay, so if you divide and multiply it, what we will get? So 8, just divide and multiply it. 7 cos. We can do one more thing. If we, because we need to find out the analog frequency only, and here it is also not omega is radian per second, right? It is a angular frequency, radian per second, and the frequency is represented by f. It is in hertz. Okay, so again just remember it. Here we need to find out not in form of omega. It is we need to find out in terms of f. Okay, so what is omega is equal to 2 pi f. So just we have to remove the 2 pi. So if we rearrange 2 pi, we have to just save it. Okay, 2 pi. So what we will get here? Here, what we can write 2 into 5. So if we take 2 here, so you will get 15, right? 15 into 10 to the power 3 divided by 8. So 7 cos 2 pi into 15 into 10 to the power 3 t divided by 8. Now just divide it. 15,000 divided by 8. What you will get? You will get 7 cos 2 pi into 1875 hertz. You will just divide it. Okay. So from here you will get this frequency f 1875 hertz. Okay. So option D is the correct answer. Yeah, option D is the answer. Directly we can do it also, but we have to save this 2 pi because they are not asking in radian per second, they are asking in the samples form. Okay, this is option D is the correct answer, not this. 1875 hertz. Okay, so okay, I hope you have understand this question. So can we move to the next question? Have you got this question? When you are solving this type of problem, just check by options also in which term what they are asking. Okay, okay, so moving to the next question. So next question is which of the following is the correct Euler's expression? So which one of the correct Euler's expression? Please answer this question. This is a basic simple question. What is a Euler's expression? So already we know that Euler's expression in in general Euler's expression represented by e to the power j theta, right? So what is Euler's cos theta plus j sin theta? It is a Euler's expression, but here it is given in the form of e to the power minus 2j omega t, right? In place of theta, that means theta, it is a minus 2j omega, sorry, 2 minus 2 omega t it is. Okay, what will be the, in place of theta we have to put just 2 omega t. Here minus expression is there, so this minus will come here also. So minus j sine 2 omega t. Okay, so option B is the, yeah, option B is the correct expression. Option B is the correct expression. Correct Euler's expression. Okay. Okay. So moving to the next question. If an input x of s is applied to a system and output is y of s, then the transfer function of the system is. So all of you, I think you know this. So can you just answer in the chat box? Here the input is x of s and output is y of s. What is a transfer function equation for any system? Yes, option C is the correct answer. Just remember, the transfer function is defined as the transfer function is represented by h of s, and h of s is the ratio of Laplace transform of the output signal to the input signal. Okay, so option C is the correct answer for this question. Okay, so already all of you have given answer in the chat box. So moving to the next question. So next question is, which of the following defines the delta function? Option A, there is a point 1 at t is equal to 0 and 0 everywhere else. Option B, there is a point 0 at t is equal to 0 and 1 everywhere else. Option C, 1 for all values of t greater than 0 and 0 elsewhere. Option D, an impulse response of area 1 at t is equal to 0 and 0 everywhere else. So just answer in the chat box. Yeah, yeah. Option B is the correct answer. Correct. What is the delta function? Already we know that it is a 1 at t is equal to 0 and everywhere it is represented as a delta function, or t is equal to 0, it is 1, right? For t is equal to 0 or 0 everywhere. It is a representation of delta function. It is also known as a impulse function. So option D is the correct. An impulse of area 1 at t equal to 0 and 0 everywhere else. Okay. So moving to the next question. So next question is, which one of the following is a transfer function of an integrator where m is a constant? So what is the transfer function of an integrator circuit? Integration of any value m dt. What will be the Laplace transform of integration? So for differentiator already we know that dy dt of any constant. So what will be the m by s? Sorry, m into s for differentiator, and for integrator it is m by s, right? Laplace transform. Which of the following is a transfer function of an integrator? So transfer function of integrator is m by s, where m is a constant. Okay, so option B is the correct answer. Yeah, option B. Let's explain option A in a previous question. Oh, okay. Option A, there is a point 1 at t is equal to 0. They are saying at t is equal to 0, it is 1. Point 1, they are asking point 1. Okay. And 0 everywhere else. It is not a point 1. For delta function, it is a it is a one impulse function at of area 1 at t is equal to 0. Okay, not a point 1. Okay, so just remember there is a point 1, not a point 1 at a 0 at t equal to 0. It is always impulse of area 1 at t equal to 0. Okay, so I think you got this. So moving, already understand this question. Already this is a basic question. So what is the transfer function of integrator and transfer function of a differentiator? The transfer function of a differentiator is m into s, and for integrator here it is a m by s. Okay, so option B is the correct answer. Moving to the next question. So next question is, how many times more intense is a 60 dB sound than the 30 dB sound? How many times more intense is the 60 dB sound to a 30 dB sound? So what will be the answer? You want to try this question? Try and answer in the chat box. Yeah, option B is the correct one. But how you can solve it? So already it is given in a dB. So we have to change it. Okay. So let's, I is the intensity of the sound, and I naught is the initial intensity. Okay, so let's, L is any value 10 log I divided by I naught. Okay, so L1 is given, that means 30 dB, and L2 I am just making assumptions. L2 is a dB, 60 dB. So it is 10 in the dB. So again we have to convert it. So 10 log I1 divided by I naught. So if I1 just L1 is 30 dB. So just I naught is the initial intensity. Okay. So and for this it is a 10 log I2 divided by I naught. Okay. So just L2 and L1. Okay. And L2 is represented by 10 log I2 divided by I naught. So just you can solve it many other ways also. Just I am trying to solve it in one way. Okay. So 10 log I2 divided by I naught, right, minus 10 log I1 divided by I naught. I am taking just one initial intensity is any value. Okay, just making it. So we can write it like this: 10 log I2 divided by I1, because I naught will be cancelled out if you take it. And here L2 is 60 dB and L1 is minus 30 dB. So you will get 30 dB. 30 dB, and just remove it from here so that I can. Okay, so 30 dB, 10 log I2 divided by I1. Now convert it. So 3 log I2 divided by I1. If you here base 10 is there everywhere. Okay, so again if you change it and then not a logarithm, so you will get it I2 divided by I1 is equal to 10 to the power 3, right? If you just not in dB they are asking, just convert it in dB to a normal scale. Okay, so from here you will get I2 is equal to 1000 of I1. So how many times more intense 60 dB sound than the 30 dB? That means 1000 times. Okay, so 1000 times. Option B is the correct answer for this question. Okay, so 60 dB sound 1000 times more intense than 30 dB sound. Okay. Okay, so these are the questions related to week 1 content and some basic problem set also. So it maybe help you to solve your assignment problem. So now questions have been completed. So if you have any doubt, you can ask. Otherwise, thank you everyone. Thank you for the joining this session. Now the questions problem set which I have taken for this week is completed. Okay.
Thank you, ma'am.
Yeah, anyone have any doubt, you can ask now. Otherwise, we can close this session.
Thank you, madam.
Thank you, everyone. Thank you for joining this session. Now, we can close this session. If you don't have any doubt, you can leave it. If you don't have any doubt, you can leave it.
Hello.
Yes.
Ma'am, will you share these questions in the portal?
Yeah. I will share it. These questions, I will share it.
Yeah. Thank you, ma'am.
Yeah. If you don't have any doubt, you can leave the session. Otherwise, you can ask your doubt. Yeah. Thank you, everyone. Now, if you don't have any doubt, you can leave the session. Anyone? Anyone else? Have you any doubt? Otherwise, we can close this session. Aparna and Kubi, anyone? Okay, ma'am can get the solution on this PDF. No, you will not get the solution of this on this PDF, but you will get the YouTube video link from that portal only. Whatever we are teaching, the YouTube video will be available there. You can subscribe that channel. Whatever we are going to discuss here, everything you will get on this video. The video, the whatever session I am taking, this is a live recording sessions are also available on that portal. Okay, so from there you can see the YouTube video and get your solution again. Not in this PDF, the solutions are not available, but which option is correct, that is I will put it in that PDF. Okay. Okay, yeah. Thank you, Kuvi. Now, if you don't have any doubt, you can leave the session. Now I'm going to close this session. Okay, okay, everyone. Thank you. Thank you for joining this session. Now we can close this session. Okay. Okay, bye, everyone.